My name is Miroslav Valjača and I'm Senior Application Manager for Analog Products from SMSC. Today we are going to talk about reference design on UCS100 series product. We have evaluation board, which you can see here, which is done based on our suggestion for the reference design. So everything that you can see on the reference design you can find also on our evaluation board. Evaluation board schematic is presented and you can see different functions around UCS part and how to connect them in a real world application. First thing that we are going to explore is power supply around UCS1000 series part. Here we can see power supply on the left side entering as a system 5 volt power supply. This power supply can be split now on a VDD, which is provided power supply for the logic of UCS1000 series, and 5 volts power supply for VS, which is power switch going to the USB power port. This power supply needs to be decoupled on the chip level, so we can see decoupling capacitors on the input of the VDD pin of the UCS1000 series, as well as coupling capacitors on VS pin on UCS1000 chip. The capacitors decoupling VDD pin are smaller than VDD because of the requirements of the chip. Also, we can see the big bulk capacitor on the output of the UCS on VS bus, and that capacitor can be somewhere in the range of 100 to 200 microfarads. It's a very application specific value. Also, there is a ESD protection diode on the output of a V-bus that is going to USB port. This diode has a function to protect in the case of ESD event, as well as to protect in the case of reverse polarity. We can see two fuses that they are put on this schematic. One is on the input and the other one is on output. Per UL category, UCS1000 is intended only for low voltage supplementary overcurrent protection in telecommunication circuits and is not suitable for branch circuit protection. A suitably rated positive temperature coefficient resettable fuses are recommended as primary protection on VS or V-bus side of UCS1000, depending on system topology and or requirements. Fuse F1 is shown here in both positions for illustration purposes only. Now we are going to explore the data signal path through UCS1000 series. We can see that the system USB data coming from embedded controller or the system are coming from the left side, entering directly UCS1000 series and going to exit after processing through the high-speed switch and emulation profile on the DP out and DM out, going to the ESD protection components. ESD and EMI performance is a system dependent and cannot be guaranteed by use of UCS1000 series. Factors such as PCB layout and use models must be a key consideration for specific system solution. ESD diodes and the common mode choke, if required, must be selected carefully as USB signal integrity can be affected by their use. Now we are going to explore control parts that are going to put USC in a certain control state. On the left side we can see control signal inputs, which are power enable, emulation enable, M1 and M2. Power enable enables only and controls only power switch, where emulation enable M1 and M2 controls charge emulation mode and can be used in conjunction or only by SM bus. On the left side we can see the latch signal, which is power switch fault handling selection. If it's connected to the ground, auto retry will occur. When we connect it to the VDD, it will latch in on fault and stay in that condition. S0 is going to be a touch detection enable or disable. So if it's connected to the ground, it will be auto detection will be disabled. Connecting to the VDD, we will enable auto detection. Power enable polarity can be selected with a pull down resistor or tying to ground or VDD. Current limiting selection will be the last pin that's called I limit, and with the pull down resistor we can select the level of the current limit that we want, or if we want to disable this function, we will just tie it directly to VDD. UCS1000 family has also two digital output signals. Two digital output signals are event alert output and a touch detection. Both of these signals are open collector, so they need to be or collected to VDD through the pull-up resistors, or we can use a LED diodes to optically alert about the state of the chip.
For more information, visit smsc.com.